All right, let's find some key features of this function so that we can graph it. We're looking for x-intercepts. Okay, we're looking for holes, vertical asymptotes. We're looking for horizontal asymptotes. And let's look for a y-intercept. Okay. So x-intercepts are going to happen on top. So we're looking for the factors that only are on top. Okay, we need to get an output of 0. An output of 0 is going to be when the numerator is 0 and the denominator is not 0. So our factors that are only on top are x plus 2 and x plus 4, which are going to cause x-intercepts at x equals -2 and at x equals -4. All right, our hole is going to be what happens when we get 0 divided by 0, which means we need to have a factor that is on top and also on bottom. So our hole is going to happen at x equals 5. But what is the y value of the hole? You may remember that what we should have to plug into is the function with the whole factors canceled out, because they are not going to affect the output. Okay, they are the same on top and bottom, so it's not going to change our overall answer. It's just causing the hole. So we're going to plug in 5, so we get 3 times 5 plus 2 times 5 plus 4 over 2 times 5 minus 1 times 5 plus 3. So what do we have? This is 3 times 7 times 9. This is 2 times 4 times 8. So 3 times 7 is 21 times 9 is 189. Okay, 189, and then 2 times 4 is 8 times 8 is 64. So our y value is 189 over 64. Don't bother simplifying that. 189 over 64, that's our hole. Okay, vertical asymptotes are going to be the factors that are only on top, or sorry, only on bottom, because we're dividing our non-zero number by 0, which is going to cause an output of infinity, causing vertical asymptotes. So those happen at x equals 1, x equals 1, and at x equals -3. Okay, horizontal asymptotes are determined by comparing the degree of the numerator and denominator. So we can see that we have a degree 3 over a degree 3. So at infinity, the numbers are going to become so comparable, since they have the same degree, that they're going to cancel each other out. We're just going to be left with these coefficients, which the fraction coefficients, which is 3 over 2. So we have a horizontal asymptote. At y equals 3/2. Now for the y-intercept, all we have to do is plug in 0 for x. So just like we plugged in 5 for x up here to find the y value of the hole, we're going to plug in 0. 3 times 0 plus 2 times 0 plus 4 over 2 times 0 minus 1 times 0 plus 3. So what do we have? We have 3 times 2 times 4, and we have 2 times -1 times 3. So that's 3 times 2 is 6 times 4 is 24. 2 times -1 is -2 times 3 is -6. So that's going to simplify to -4, which is nice. So our y-intercept is at 0, -4. So now we have enough key features that we can try to graph this. So let's do that. Okay, so let's put some key features on here. So first we have x-intercepts at -2 and -4. Let's just double check that. Yep, -2, -4 looks good. So we are just going to put some x-intercepts here. We already have them labeled as being -2 and -4, so we don't necessarily have to label them again. All right, we have hole at 5, 189 over 64. Let's hold off on that for a sec, because that's kind of a weird number. We want to make sure that we put it in the right place with relation to the asymptote, right? So let's put the vertical asymptotes in at x equals 1 and -3. Okay, x equals 1. Okay, and then -3, where's that going to be? It's going to be between -2 and -4. So we have to make sure we put it between our x-intercepts. Okay, there's our other vertical asymptote. All right, let's put in the y-intercept at 0, -4. Okay. And then what next? So we haven't put in the horizontal asymptote yet at y equals 3/2. So we'll throw in a horizontal asymptote here. All right, so then the question is this bigger or smaller than 3/2? And the answer is that it's bigger than 3/2. because 60, if we just approximate as this is being 60, 60 goes into 180 like 3 times, right? So we have a number that's roughly equal to 3, whereas this is 1.5. So the hole is going to be above the asymptote, and it's at 5 comma 189/64. So we're just going to put it like over here, put our hole. Okay, do we have all our key features on? Yeah, we do. So what's going to go on with this hole? Well, we have to approach our horizontal asymptote eventually, right? So we're going to approach that. Okay, we know that this curve can't possibly come down here because then that would cause another x-intercept. And then what happens when it runs into the vertical asymptote? Well, it has to go up. Because, again, if it goes down, what's going to have to cross eventually? This, and there's no x-intercept there. Okay. So there's 2 ways that we know that this goes down like this. Okay, one way is that it must go opposite from this arrow on this side of the vertical asymptote. And the other way is that the only way it could possibly go up is if it crosses right here, and we know there's no x-intercept there. Okay. So it does come up and cross through here, though, and then it's going to have to go up against this vertical asymptote. Okay, this is going to have to approach our horizontal, and then it's just going to come down like that, and there is our nice sketch of our graph.